this one hurts. No, hmm. If you try doing the trig sub, let's see, sine square is equal to what? This is like, I'm sorry, no, 2 sine square. Then this would be 1. So 1 minus is cosine 2x, so then that means that it would be 1 minus cosine 2x, right? And then 2 cosine square of x is equal to 1 plus cosine 2 of x. So what I'm doing here is, what if I let, oh no, this is x minus 1, not 1 minus x. Oof, okay. So no trig sub, maybe. Well, I mean, no, 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 no. You can't do trig sub with this. This is ugly. I mean, if you do, okay, x plus 1, x minus 1, this is equal to x, wait a minute. No, yeah, I can't do that. I'll get x squared minus 1, x plus 1, or x squared minus 1, x minus 1. So if I try doing any trig substitution, like if I let secant theta for x, right, then this is what, secant theta plus 1, and then tangent theta, like this does nothing. And this gives me no, I don't know, this won't do anything. It's hopeless. This is all hopeless. This is all hopeless. Okay. Well, everything seems to be an inverse. Oh, I cannot do more undos. Okay, so let's try inverse jailbreaking. So, what is that? Well, the whole concept of inverse jailbreaking is, so what I'm going to do is I'm going to follow this. So if you remember the inverse sum, right? If you remember the inverse sum, and this equals like some constant answers, right? So let's say I'm just call this k, like some answer k, because it's a constant, so we don't care. So this is my original integral. This is my original integral. But what if the inverse was an easier integral, right? Then all I have to do is solve for the inverse instead, right? So this is what inverse jailbreaking is you just solve for the inverse. So yeah, I did not make up this method. I learned this method from, it was a textbook from Caltech, and it was the only textbook that showed this technique. But I think they called it something else. They called it like, what, substitution by parts? I don't know. But it was from a Caltech calculus textbook. But yeah, this is, but I'm calling this inverse jailbreak because it's much easier to look at. So instead of solving for the function, we solve for the inverse, and then you get your answer, right? So, but the thing is the inverse any easier? Is it really any easier? And I'm about to find out. I'm about to find out right now. So we have inverse tangent x plus 1. Well, x minus 1. So this is equal to, let's see, minus 1 plus 1. So I just want to. So what I'm doing is I'm gonna make it like this, and I want to cancel it out. So it's gonna be like 1 plus 2 over x minus 1. Right. So that's what this is. So I'm making it easier for myself. So now this is tangent of y square minus 1. Okay. I'll divide by 2. So now this is just 1 over. So now what we have is x minus, so x is equal to 1 plus 2 over tangent square y minus 1. So this is our inverse function. And I mean, it looks easy. It looks easy. It definitely looks nicer, less monstrous. So, okay. But then we have to change the balance. So, okay. So then we will have integral of some constant minus 1 plus tangent square minus 1 dx. Okay. But then we have to make sure that the function, we start plugging in the function here. Plug in negative 1. 1, this is 0. So 0 is here. All right, plug in negative 2 into this function. This is negative 3, negative 1. Okay, so we get 1 over 3. So the inverse tangent of 1 over root 3, this is equal to, I actually don't know. We have a half root 3, 2 from sine, cosine. This looks like, I might actually have to pull this up. So we have a half here. So this is pi over 6. Okay, so we have pi over 6. And we can just use that negative to swap the bounds. Okay, cool. And so what this means is that, well, remember that we had our original function plus our inverse, and it was 0 pi over 6. Don't forget, don't mess this up, you know. You would switch it and then put it like this, but no, this is the correct way, because this, evaluating this gives us 0, evaluating this gives us pi over 6. So this is 0 minus negative pi over 3. Okay, so this is pi over 3 minus this integral. So that's what this integral equals. All right, time to jailbreak the hell out of this monstrous integral. Okay, so now we have pi over 3 plus 0 to pi over 6. We have 1. All right, so now we have this tangent square. Let's deal with this. How do we deal with this? Well, let's see. If I multiply cosine square, if I see 2 cosine square, and then multiply cosine square here, I get sine square minus cosine square. And then this would give me 0 to pi over 6, 1 plus, and then 2 cosine square, that's 1 plus cosine of 2x. And then this is my, so I'm just going to put a minus here. Right, so this is minus cosine of 2x. Oh, thank heavens! This is so much easier to work with. So pi over 3. This is x. Whoa, actually, this is 1 minus 1. So actually, it cancels out. So technically, we only have negative secant 2x. So this is negative. So this whole part is just negative secant of 2x, right? So this is negative ln, oh, sorry. Don't forget that this is 2x, so we have to have a half here. Ln of secant 2x plus tangent of 2x, 0 to pi over 6. Okay. Well, plugging in 0, we get, is that equal to 0? That does equal to 0. Oh, thank heavens. Okay, so we just have to plug in pi over 6. So then we get pi over 3, and then plug in pi over 6, that gives us, pi over 3, that's what? Pi over 3, cosine pi over 3 is half, so this is 2. So this would be 2. Right? Wait, cosine pi over 3. Wait, what am I doing? Cosine pi over 3. A half. Yeah, this would be 2. 2 plus, and then tangent pi over 3 would be root 3. So this would be root 3. So in that case, we have pi over 3 minus 1/2 ln 2 plus square root of 3. And this is our final answer. Okay. Inverse jailbreak for the win.